So this is another method. Now this method doesn't always work, but if it does, it's a very nice method. So we already know that if we take the derivative of our critical point, it's going to give us 0. And so now if we take the second derivative of our critical point and it comes out positive, then we know that we have a concave up at that critical point right there, making this a minimum, a relative minimum. And if we have a second derivative of that critical point and it's negative, we know it's concave down, making it a relative max. So if you take the derivative, set it equal to 0, it gives you the critical point. You plug that critical point in the second derivative, it'll tell you if it's a max or min most of the time. So let's try one. F prime of x equals, and then we get 6x squared plus 6x minus 12. Set it equal to 0. Divide everything by 6 or factor out the 6. And factor it. And so we get x equals -2 and x equals 1. So those are our critical numbers. So normally we would draw the line and then put them on there, -2 and 1, and then do the increase, decrease kind of thing, right? And find out if they're max or mins. So it's a little bit quicker now. So we're going to take a second derivative of our function. And so that would be 12x plus 6. And then you would want to set it equal to 0, but we're not finding points of inflection or increase or decrease. We're just looking for max and min. So if we take that -2 and we plug it in, this comes out to be negative. And so if it's negative, we know it's concave down, making this a relative max. And then if we take the second derivative of 1, plug it in, it comes out to be positive. So that means it's concave up, making it a relative min. So we know we have a relative max of, and now you can just take your calculator and plug -2 into the original function to find out what that y value is, but I've already got it graphed. So if I do trace -2 and hit enter, you can see that's our max. You can see at -2, it's concave down, making that a maximum. So we have a relative max at -2, 13. And we have a relative min of, and we would do the same thing. We would plug our 1 into our original function, trace 1, hit enter, and you can see we have a relative min at -14. You can see there's your concave up. So if it comes out concave up, we know it's a min. If it comes out concave down, we know it's a max. So -14 at 1. So there you have it. Now if this comes out to be 0, well then you have to go back and use the table that we've done before to find the intervals of increase and decrease, like here. We can see it's increasing, decreasing, increasing. So we know it would be increase, oops, wrong color. It would be increase and increase and decrease, making this a max and making that a min, just like we have down here. So if you don't want to look at it graphically, you want to do it purely algebraically, take the derivative, take the second derivative, plug those critical numbers into the second derivative, and it'll tell you if they're maxes and mins. All right, let's try one more. So find the critical points of this one. And so we have a domain issue here. So x cannot be 0. So we do our derivative. So first let's rewrite our function. And then we'll take the derivative. So that's 1 minus 1x to the -2, which equals 1 minus 1 over x squared. Putting them together, we get x squared minus 1 over x squared, which would be x minus 1, x plus 1 over x squared. And so our critical numbers would be -1, 1, and 0. Now this is why you want to always make sure that you put this back into its fraction form so that we can see our zeros and d and e's. And then also to go back to your domain and go, oh, x can't be 0. it was already undefined to begin with, so we can't have this as well. So we cross off the 0 because it's not a critical number. The only critical numbers would be -1 and 1. So again, make sure you always rewrite, put it back in fraction form, factor to find your values, and there you go. And then if you check your calculator, you'll see that there were already 2 values right there. That was a max and a min. So to make sure that you do have them on there. Okay, so now we take those numbers, and we don't have to do that whole line or table. We're just going to plug them in. So let's find our second derivative now. And we're going to use this one. So that would now be 0. And then that would become +2 x to the -3. So this is 2 over x cubed. And we just have to plug in our points. And so that is negative, which means we are concave down, which means we have a relative max right there. And then we do +1, which comes out positive, which is concave up. So we have a relative min. And so that means we have a relative max of what at -1, and a relative min of, we don't know yet, at +1. So if we take those -1s and 1s and we plug them back into the original function, it will tell us our max and min. But we're just going to use the calculator by doing trace -1. And so -2 is our max. Trace 1. And our relative min is 2. That's why we have to say relative. And there you have it. So there's a complicated one and a nice polynomial. So using the second derivative is a way to tell if it's a max or a min. Do you have to know this method? No, you've already got this method. But it's nice to have.